So we're going to start off with a few statements about some attack surface reduction, have a lightning round of some tips in some various categories, and then we'll hopefully have some audience participation at the end where we get some of you guys' ideas, and you can ask questions if there are any. And just a note, no reason to have to take notes or memorize anything we're talking about. We'll have all examples are already posted on GitHub on a gist that's linked here, so when the slides are available, you can use that link. All right, so without further ado, get going talking about some of our attack surface reduction. So first and foremost, when working with the Windows platform, we always want to use the most recent version of it. So in this case, it's Server 2016. We want to take advantage of the software development lifecycle work that the developers at Microsoft have been doing, and the only way to do that is if we're actually running those bits. And furthermore, we want to use the core installation type, which has a dramatically reduced surface area. That means there's less servicing that needs to be done, there's reduced management overhead, and there's the reduced attack surface. Just to put some numbers to it, there's approximately 40% fewer services running by default on the installation, and it takes 50% less disk space. So server core is a dramatically reduced surface, but there's still more that you can take away from it after you've installed for most applications. So SMB v1 is obviously something that you want to disable on these systems unless you're dealing with really old legacy systems. And that's actually handled automatically as of the RS3. Disabling IPv6 tunnels and these other services pointing out in the AD security blog are good ones for note. And then there's several services that can be disabled as noted by the Microsoft docs. There was a Project Zero blog post talking about the WinHTTP auto proxy service. And then from our use with Pi, we don't have use for the diagnostic tracking, SNMP trap, or SAC server in most cases. So we know those are something you can eliminate. So we get people rolling their eyes sometimes when we talk about PowerShell and how great it is and how much we love it. But, and especially when there's stuff like PowerShell Mafia, building exploit frameworks like PowerSploit. But hackers have been living off the land with PowerShell because it's a powerful tool and there's a lot you can do with it, especially, there's just so much you can do with it. But we can get the power of that as sysadmins, and it's about the proper use of the powerful tool, not about getting rid of the power and handcuffing yourself. And in the latest platforms, there's been a lot of security features that have dramatically improved in PowerShell so that you can have script block logging, system-wide transcription. When combined with Windows event forwarding, that gives you, that puts incredible amounts of fingerprints and footprints left when an attacker does things on your system. And of course, PowerShell follows all the authorization and authentication of the Windows platform, and it's encrypted by default. So there's a great overview of these features in this article linked here from Microsoft on MSDN, but I really like this table that shows essentially there's functionality you're going to get out of scripting, and you're either going to use PowerShell or you're going to use some other scripting language to do it, and PowerShell has more of these security features to do so safely and in a way that you can monitor and detect aberrations. And so to that end, at OSIsoft, we try to empower our customers to use PowerShell to administer to our tools. And so we've done that with our system management tools, with an auditing script that we provide where people can audit their configuration, and we provide some guidance to align with best practices. And then we're even more recently trying to align with configuration as code paradigm. And so we're embracing desired state configuration, and we're creating Pi resources for that. So this configuration as code paradigm is really taking off, and we're trying to do our part to facilitate our customers' use of it. So if you're not familiar with desired state configuration, DSC separates the intent, what do I actually want to do, what do I want to do, from the actual execution of how do I actually do this. So it decreases your complexity of automation, makes it more agile, et cetera, et cetera. There's a broad scope to DSC. It can be used for hardening, for baseline configurations, and it can be done for very specific things that maybe only happen at sites and vary across sites. But it gives you it allows you to put in a declarative fashion what you want, and then actually run that human readable config file to actually make it happen. So an example here, a trivial one, is just making sure that SMBv1 feature is not present on the system. So, but these configurations can be very complex. That's one of the trivial examples. So compatibility is great for this because you can configuration as codify any app if it can be manipulated or administered with either C# or PowerShell, which is pretty much anything on the Windows platform. And so the PySystem prototype is the PySecurity DSC module that we have in our GitHub repository. And again, we like it because it has this declarative format, so it can act as functional documentation. And it's a collaborative, it makes collaborative work easier because, for example, you can share best practices. Microsoft publishes all of their security baselines for their OS as GPOs. And there's a baseline management module where you can port those GPOs to the DSC format with a one-liner. Those other lines above it are just to install the different modules. Okay, so moving on to some application whitelisting. Just a couple notes about AppLocker. We've used AppLocker and we've encouraged our customers to use it for a while. There's a lot of great aspects to it. It gives you granular control over applications. Its availability with the OS is by default, and there's audit and enforce options, so you can kind of test it out and safely try it before enforcement. Unfortunately, it's more compliance than a security boundary. The focus from it is kind of putting guardrails, not actually putting hard security boundaries, which we'll talk about in the ugly section. And it's not supported on server core editions. And you could argue this is in part because core, you're not expecting as many interactive users. But on the ugly side, there's some major limitations. Services aren't bound by AppLocker. There's different macros and scripting methods that aren't covered by it, and there's multiple bypasses that are even available as modules on Metasploit, such as the regserve32 and the install util. And so in enters Device Guard, which is the next generation of the whitelisting technology from Microsoft, available in the latest platform. And there's an abundance of documentation, great documentation on Microsoft's website about it. But I'll tell you, it can be overwhelming to look at, and you're like, how do I start it? How do I get it in place? And it's actually really easy to do the hello world setup where you just make sure all your stuff is signed and nothing that's not signed is going to execute, and that you have a fallback so that you have hashes for stuff that's not signed. And so that's basically what we have here is with a few commands, you can enable the feature, you can define a policy, and then you can verify it with standard OS utilities, and then even auditing whether there's applications that are running outside of the policy, or attempting to run rather, is very simple. It's a one-liner in PowerShell. And so there are some hardware requirements that come along with Device Guard. And so some people might not be ready to move to that from the hardware standpoint, but if you're using the latest OS, then even just generating the code integrity policies with the new CI policy commandlet can let you do some cool things. You can check running for unsigned code with this one-liner from Lee Holmes that he tweeted back in June of this year. But code integrity policies can let you do some other cool things too now. So one thing you can do, since the code integrity policy is just an XML document, you can navigate it like you would any other document, and you can identify certificates and publishers used by your applications. And this is something where you could create publisher rules with AppLocker or just update your documentation based on it. And you can also use the policy to identify any unsigned policies on your system. So then you could fill that gap by signing cat files, and that would be a safer alternative. So just to talk about briefly the relationship between Device Guard and AppLocker, they serve kind of complementary roles like a bouncer and a bartender. You get the strong, rigid enforcement from the bouncer in Device Guard, and then AppLocker is a little bit less strong enforcement, but just giving some compliance and some more granular control. So we recommend using server core and having Device Guard enabled to limit your attack surface and also limit your server access. And then if you're using desktop experience, then we recommend using these two things in tandem. And lastly, an honorable mention, there's a few easy options with UAC. The UI access one is actually by default in the US, that one's enabled, but there's also an option we see seldom used that only elevated executables only allow to elevate executables if they're signed and validated. And that one's a nice, easy thing to turn on a system. And the big thing about UAC is we see a lot of people, I know it's a stretch to call UAC hardening, but we see a lot of people who do end up turning it off. And for crying out loud, give your users a fighting chance. Let them see that something's not trustworthy. All right, I'll hand it off to Ricky.
So I'm going to talk about the communication whitelisting. Most people know Windows Firewall and connection security rules, but the area I want to focus on is Windows Service Hardening, also known as WSH. Services are attractive targets for malware. They run without user actions and always on, and they are always on the network. And most often they are often running with unnecessary privilege. There are ports open for it, and it is not limited by AppLockers, meaning AppLockers cannot restrict service from running. Luckily, we got a Windows filtering platform, and it is a development platform for developers to apply service restriction. And Windows Firewall with advanced security, that's the one we're familiar with, is implemented by using WFP. And there are setups API for setting the service restriction, and WFP has a very rich tracing capability, and it can capture very robust log information in an XML file, so it's human readable. To hardening our Windows service, we can actually restrict the network access for our service application. And I want to say it should be the responsibility of the service developer to develop this restriction, because they should already know what network resources the service need when they build the application. And the NetFW service restriction and the INetFW's rule API will allow the developer to apply their service restriction in their service. And once it is correctly set up, the rules should store in the registry key. And here is an example of some predefined registry key from the service from Microsoft. The one highlighted right now is from Windows Defender. Those are the ones that cannot be manipulated by the API, because those are predefined by Microsoft. But we could do our own one. So we could, for our own service application, we could do it in VB script, for example. First, we block everything inbound and outbound for our service, and then we allow inbound port 5450 for our Pi server. That's our company product. And we can actually do it in a modern way with PowerShell. It is basically doing what the VB script did, except it has we are using the new PowerShell command called new net firewall rules, and we are manipulating the configurable service store. And once everything is set up, the service restriction for our Pi server will show in the configurable key as a configurable key inside the registry. And we can actually delete everything, and then all the service restriction will be removed. And wait, did someone say registry key? So we can actually use desired state configuration to help us repeatably set the service restriction. So here's the example, and basically it just works as the VB code or the PowerShell script that we just mentioned. It is basically the same thing. Talk about the difference between the WSH and the window firewall. The window firewall cannot be disabled. It is the WSH cannot it's evaluated before the firewall rules. So let's say firewall is turned off, but if you have WSH enabled, your service will still be restricted. And WSH is enforced by kernel, not by firewall service, which is much more powerful. And it cannot plan access, it can only restrict access. The downside about WSH is it doesn't have a good graphical interface. You have to use PowerShell or like code to manipulate that. Also, you have to use Windows Server 2012 or above to have the PowerShell command available. So I'm going to pass the mic to James. Thanks.
Thank you, Ricky. So I'm going to talk about a few additional measures for server hardening here. I'm going to start with TLS. So I'm sure everybody here is familiar with TLS in terms of securing the communications to and from your servers. But it's important to note that TLS relies on ciphers, and not all ciphers were created equal. These TLS ciphers, the weak ones, can affect your web traffic and just traffic that's secured by Windows Integrated Security, which also uses TLS. I'll speak about that more in a few slides. There are a number of weak and outdated protocols that are enabled by default out of the box in Windows for backward compatibility, and we would recommend disabling the ones that you can. It's important to note that you may require some amount of backward compatibility, so try to be aware of that before disabling them so that you don't DOS yourself when you're disabling them. So there are a number of ways to implement these configuration changes for your crypto suites and protocols. An example of an easy one is this tool on the left, IIS Crypto. It's by Nartek Software. It's a simple GUI that lets you configure your ciphers and suites on a single machine. There's command line options as well if you're on server core. But if you want a more scalable solution, one such option is desired state configuration, which Harry spoke about earlier, and he actually also created an example configuration that will apply these crypto baselines, these hardening practices to a machine or many machines, depending on how you implement it. So as I mentioned, Windows Integrated Security, when securing connections, can also use TLS to offer secure communications. In the case of Windows Integrated Security, the handshake for TLS is performed by SSPI instead of the public key infrastructure. This form of secure communications is actually relied upon very heavily by the Pi system. That's what we use for all of our secure communications to the Pi Data Archive and Pi AF server. Aside from the secure communications, there are additional benefits, including built-in auditing in the Windows platform in the event viewer. And for us, we have message logs that go into the Pi Data Archive message logs showing you what authentication method was used and even what ciphers were used for that connection. So if you're using Windows Integrated Security to protect your traffic to your front-end servers, it's great to also use it to protect the traffic to your back-end servers. So let's say you have a front-end server that needs to impersonate a client. That connection can also be secured using TLS if you use Kerberos delegation to make that connection. We highly recommend doing away with unconstrained delegation and instead whitelisting those services that are allowed to delegate. That's done using constrained delegation. If you're going to do that, a great way to do it is using resource-based constrained delegation, which is a newer paradigm for configuring it. As an example of the difference is there on the right. You can see the top is traditional constrained delegation, where there's actually a property you set in Active Directory on the front-end service. In this case, the example is a web server that says it's allowed to delegate to the back end. In resource-based constrained delegation, you set a property on the back end that says this service is allowed to delegate to me. This has a few benefits. So first of all, the back-end party gets to decide who can delegate to it, which makes sense. It's the trusting party in that relationship. And second of all, it's configurable by admins of that back-end resource. You don't have to be a domain admin, as is typically the case with the traditional constrained delegation. And furthermore, it's doable with 2 lines of PowerShell. There's an example there in the bottom right. So one of the core principles of hardening is lease privileges. Usually in Windows, that's done using a service account for your applications. But traditionally, those service accounts will be in the form of shared user accounts. But we would really recommend using group managed service accounts instead of that, because there are a number of benefits they provide. So they let you perform passwordless installation for your services. They use strong passwords behind the scenes that change automatically. And they have lease privileges on your network by default. So on the right, you can see an example there of the type of password a GMSA would have. You wouldn't really interact with this password ever, but it would be automatically changed every 30 days on your services. This can protect you from the trap of having a shared user account as a service account, where you might have insecure passwords that may rarely or never get changed depending on how your policies are implemented. It's not all good with GMSAs, so there is a requirement for support by the application you're running them with. If it's not run in Service Manager or IIS, then your application would need to explicitly support GMSAs. And it can require additional coordination with AD admins to create and install these managed service accounts. So I want to talk about just-in-time access, which is a cool principle. Simply put, it's just restricting access to privileged resources to when it is needed. So instead of having long-standing membership of privileged groups that your admins would have, you would grant access to those groups on a need-to-have-it basis through a request process. And then after they have used that, that access would expire automatically after a certain time. There's a Microsoft offering that does this for you in Microsoft Identity Manager 2016, but you can also do this for free in PowerShell by creating temporary groups with this MSDS entry time to die attribute set that will have Active Directory automatically delete that group when that time expires, therefore removing the access. There's a great example script on the Hey Scripting Guy blog by Ian Farr that is just it basically gives you a one-liner to add a user to domain admins, enterprise admins, or schema admins with that expiration time automatically, and there's some nice features to it. But the mechanics behind it can be set with other PowerShell or other implementations that call to AD. Last thing I'm going to talk about, there are a number of special well-known SIDs or SIDs in Active Directory and Windows that provide information beside group membership. So this can be information on user privileges or token context. The most useful ones that we found are the 2 that are on the top of that list on the right. They specify whether an account is a local user, and furthermore, whether that local user is a member of the local administrators group. I say that's the most useful because there's already a Windows policy that implements or uses those SIDs to implement a restriction if you set it to disallow network login from local accounts, potentially just if they're admins, if you would like to disallow that level. But there are other interesting SIDs in there. Namely, I like the token that there's one that specifies whether the token was built using a multi-factor approach. And there are SIDs that specify the minimum consistency level there. I say that they're interesting because we haven't found a good way to implement those in Windows policy, but they pose some interesting potential in terms of applications implementing them for hardening, or perhaps future Windows policies that would allow you to use those to further harden your servers. With that, I will pass it back to Harry, who's going to talk about SysMON logging.
Thanks. Yeah, so I think a lot of people are familiar with SysMON, but in case you're not, it's a part of it's a sysinternals type utility from Microsoft that you can use to monitor and write events to the Windows event log, having to do with process creation, change files, retroactively change creation times, network connections. There's all sorts of different indicators that are surfaced by this utility and written to a single log, which again, when combined with a Windows event forwarding, can give you good visibility of your system. It's extremely easy to start with this utility though. You can install it with just this simple command on the board here with a -I switch. And then later on, after you've played around with the default, looked at the information coming in, you can apply different configurations. And one thing is that there can be, especially with the default configuration, it can be quite noisy, so you might want to increase the size of that log so that you don't turn over your logs too soon. Another neat thing to note is that when a process is created, it includes a hash of the image, which is a neat feature. And so where the real cool aspect of this utility has come in is that there's been a lot of community support for it in terms of people publishing their different configurations that help filter out the noise and reduce it to just actionable information. And so in terms of some powerful configurations that can be done, you could take all that huge set of network connections and you can look at suspicious attributes such as directories, processes, or ports and limit it to just the actionable anomalies. So if something is happening in the users group and you see like regserve32 in there, then you might think that it's somebody trying to bypass AppLocker, or if you see port 23, you might think somebody's using Telnet. And then on the other side, you could have file creation. You can look at different locations and extensions for anomalies, see if there's particularly dangerous files, see if there's PowerShell scripts coming out of the download folder, etc. But there's a couple cited blogs here from Moti Bani from the Windows Security blog. I believe that's from the Windows Security blog, where he has some really interesting insights into this tool, and both Moti Bani and SwiftOn Security have posted a lot of really great configurations on GitHub. Okay, so that's all the material that we had prepared to this point. Just as a note again, if you do I have it? Yeah. If you missed anything on this or want to see these again, you can go to the gist on GitHub and look at the files there. Oh, sorry, let somebody take a picture. But then we'll go back and if we have any time left, it looks like we have a few minutes. So we'd like to hear from the audience if you guys have any things you'd like to share about what are you doing, what's your favorite thing to reduce attack surface on the Windows platform? What technologies are you guys using to try to improve manageability? Or what are you asking asset owners that you work with? Sure.
You say that you use
Need a microphone.
I saw you use a whitelisting for the protection. Did you try to use the McAfee also? Did you work with that? And
Sorry?
did you try to use the McAfee whitelisting software?
Oh, not specifically.
No. Okay.
I think the question was, did we use the McAfee software for whitelisting? And it's not any slight on McAfee or any other vendor. It's just our advice. When our default advice is usually to seek to maximize the capability built into the platform itself. So if there's a feature that's default available in the platform, the Microsoft operating system, then if we figure out how to support that and the best practices for that, we can surface that to our customers, and 100% of them have that available to them to use. Whereas if we go to another third-party solution, those can be great solutions, but then we're narrowing our advice to a smaller subset of our customers. That being said, there's specific concepts that we apply which could certainly be used in other whitelisting applications. So yeah, I want to stress that very strongly, that we don't discourage the use of third-party stuff. We just don't publish a lot of specific guidance on it because it narrows our audience.
The system hardening approach. Are you focusing on the specific requirements for the applications which are running on the server, or you rather try to do some default, image of the operating system, which is assumed hardened, but not too much in details, depending from the application which is running on?
We're saying system hardening or service hardening?
In general, system hardening.
General system hardening. So if I was catching it right, you're saying there wasn't much details about which specific applications we were hardening with respect to?
You may switch off some services, maybe services needed for the...
Yeah, we were looking at this mainly in context of our check for are we breaking anything was mainly within the context of, say, a PyData archive or a PyAF server. So yes, some of those services that I talked about disabling, you would want to evaluate whether your applications depend on them. In the different sources that we cited from Project Zero and the AD Security blog, they were indicating that these things were generally only required by legacy applications, but obviously that's something you would want to look into before removing functionality from your environment. But we just looked at it from a Pi server standpoint, the heart of the Pi system.
Maybe I can add some more. We actually sign all our application exe when we run the installation kit. So only OSI product and Microsoft product are allowed to run on the server. So we sign that first.
Right, yeah, so when we run the code integrity policy, that helps with the enforcement of it when it's signed as opposed to just falling back to hashes. Okay, are there any other comments on that front, or should we go to the next question while we have just a couple minutes left? Okay, go to that. So what would you like to see more of from vendors out of the box with respect to hardening? And we have some categories here to inspire inspiration, but anything's fair game. Just want to hear some feedback.
From my point of view, it's quite important documentation to see what has been exactly done on the server and to document that we can then roll back the scenario. So I think this is the very important aspect, at least for our case, because we use system hardening approach for the security of as a security strategy for our endpoints protection. So documentation is one of the key aspects.
So actually, I'm glad you said that. That sets us up well, because we're right now working with EPRI on, EPRI has a technical assessment methodology. One of the artifacts of the process is a cybersecurity data sheet. And so right now we're working with EPRI to produce a cybersecurity data sheet for the PyData archive, which goes into great granular detail about what the hardened baseline configuration looks like, what data flows are involved, what security control methods are engineered into the product, and which security control methods are available to be applied at the site level. So hopefully that helps address that pain point. Okay, I think that's our time. Thank you very much, everybody.